Well, good afternoon, everybody, and welcome to the second of today's webinar sessions from Smart Vision Europe. This time, again, we're looking at SPSS Statistics. We introduced that in the previous webinar. But now we're looking at data cleaning with IBM SPSS Statistics. So for those of you who haven't joined these sessions before, you might want to bear in mind that we do record these sessions. And there's a copy of the slides that we'll be emailing out to you after the session's ended. Most of it's demonstrations, a few slides. If you do think it's relevant for colleagues who can't attend at the moment, then by all means just ask us, and we might be able to rerun it for you. The best thing to do is just send us an email. With regard to asking questions, all the lines are muted, so we ask you to use the chat panel, and if we run out of time, we will follow up with you. And my name's Jarlath Quinn. I'm joined online today by my colleague Rachel Clinton. Rachel will be keeping an eye on the chat panel and answering questions as we're going along. But as I say, we do very commonly get questions after these sessions have ended via email or whatever, and we'd be happy to answer them to you offline. And with regard to who we are, we're Smart Vision Europe. We are a gold accredited partner to IBM, also a partner to Predictive Solutions, a company called Predictive Solutions, and Data Robot. And we specialize in statistics, analytics, data mining, all that kind of stuff. And we're long time users and providers of SPSS Statistics. We also work with open source technologies such as R and Python and Spark. Most of us have a background in SPSS itself, in the sense that we worked for SPSS, incorporated at some point. I've been doing this for about 30 years now. I've worked for SPSS Statistics for IBM and for SAS Institute as a senior consultant in analytics and statistics and data mining and machine learning. That means we've got a lot of experience as a little organization across many different sectors and applications in applying advanced analytics to various problems in those areas, everything from central government to obviously commercial applications. There's too many to go into at the moment, but suffice to say that certainly the topic of data cleaning is something that applies to every single one of those applications and every single one of those vertical sectors. It's such a perennial and common problem. One of the things we wanted to do with this session is just to kind of get people schooled in how they can deal with data cleaning issues in SPSS Statistics, but also what sorts of issues can arise and what to look out for. And there are a lot of different small issues which can cause a problem for your analytics. So this is an almost universal problem for anybody who works with data, and it can take the form of errors or irrelevancies in data, and that can occur due to just simply people a typo, misplaced keystroke, entering the wrong value. You can also have, of course, inconsistencies in recording information between different data entry operators. The way in which one organization, one department records something is not necessarily the way in which another person records it, or it changes over time. You often see that. Or information is collected on events or subjects or topics that are just not applicable or not important, and therefore shouldn't really be part of the analysis and maybe should be removed from the data set. You often get things like mismatches between database tables when you ask people to give you data and say, can you give me data, on this particular topic or this particular situation, from a certain time point, let's say from 2021 onwards, something like that. They then go and have to grab that data, and it's usually very often in databases, and when they do the join between, let's say, the customer lookup table and let's say the transaction history or something like of the various customers, you get mismatches. You get transaction histories where you don't have a customer, or you get duplicate customers, or you get values which have changed in how they've been recording over time, and that in itself can mean that the data set you get is far from perfect, and you need to be able to recognize that, identify those issues, and change them. And just differences in how various systems encode or represent data. I mean, a common perennial problem is date and time fields. That the way in which one system records date or time is not the way in which another system records it. Something like Excel would record a date as probably the number of seconds elapsed since 1900. SPSS records it as the number of seconds elapsed since October 14th, 1582. Systems like SAS record dates as the number of seconds elapsed since the 1st of January 1960. They all have different time points. They all have different ways in which to represent those date and time fields. And it can cause issues. So it's something to bear in mind. So typical tasks in data cleaning would include things like identifying records of fields with, for example, a high percentage of missing values. Sometimes you're just going to get a field where most of that data is missing. And really, it might be missing because that particular topic just doesn't apply to that particular cohort or that particular group of people that you're analyzing. So, you might have a table of insurance customers, and maybe there's an insurance product that very, very few people actually have. It's a very specialist product. So for the vast majority of people, they don't have that insurance product, and the data is therefore missing. And you might wish to simply delete that field if you wanted to. A high degree of variability can sometimes be an issue. There are situations where high degree of variability can be a problem because there's just too many categories to analyze. So you'll get situations where you have, for example, a product number. And a product number, you might have thousands of those products, but that product number is only one of 100,000 different products that can be sold. So product number may not necessarily be very useful analytically, but a product category, when there might only be 34 categories, is more useful. So sometimes having too much variability in a set of categories can be a problem, or too little variability. Very common to get data where for whatever way the extraction's been done, you get data where there's no variability, where everybody lives in the same town, or everybody's bought the same product and everybody belongs to the same group, in which case, what's the point in having a field that records that if it doesn't have any variability? And other issues are going to be things like correcting values that are out of range. So typical things being people aged 199 or minus numbers. You sometimes get things like minus 99 in surveys and things like that, or minus 100, or zeros where they shouldn't occur to indicate that the data is null. But unless you tell SPSS that data is missing or is null in some way, it won't know. Identifying removing duplicate records, common issue. Ensuring variables are correctly formatted. So just things like removing decimal places. If somebody's got an age, you generally don't have people's ages recorded as 37.00. It's usually just 37. So you make it an integer value. Checking that the values in combinations of variables not contradict each other or imply errors. So males who are pregnant, that type of stuff, or car drivers who are 15 years old, that things which are contradictory. And also things like a typical task would be creating syntax, SPSS syntax, so that you can correct these issues automatically in the future. If you're going to be reading data on a regular basis and you always have to clean that data set, then you can record all of the things that you do to clean the data, to correct these issues in syntax, and build up a what you call a sort of batch job, if you like, so that next time you read in a data file from the same population, you can just automatically clean it. So I would say that there are two broad classes of errors or problems in data. One is formatting. Formatting issues can be caused by how the data were stored in other systems. So the way in which, as I said, the way in which one system stores a date field is not the same way in which another system stores a date field. And the other issue is problems with the data file itself can be caused by human error or systematic or systemic failures. So where you've got people have actually put in the wrong numbers, or where the way in which data has been recorded has changed over time, or you've got different departments not being consistent in how they record data. So problems of how the data has been formatted and imported include things like defining missing values. Can you identify what is the null and the missing value? Are there labels to describe what the fields actually are? Can you rename the field so the field's descriptive? A real issue is when number fields have been read as character string, and sometimes vice versa. And things that, as I say, variable names can be an issue, which we'll come to in a moment. But there's a lot of ways in which SPSS can end up with fairly non-descriptive variable names from a data set that it's imported, which actually originally had quite descriptive variable names. And the problems of the data itself is actual errors, inconsistencies, duplicates, and illogical relationships, as I say. Okay, data formatting problems. Let's have a look at that first of all. Let's jump to SPSS. We're going to open up a data file here, and this data file is one which has. Let me just close down my email here. There's one that has issues, and a whole bunch of different issues. And our job, I guess, is going to be to identify these issues and to fix them as we're going along. So here's our data file. It's called employee for cleaning.sav. For those of you who are on the previous session, you'll recognize this data file being the employee data set. Each row represents a different employee from a bank in I believe in Chicago in the 1980s. And one of the first things you're going to do when you read the data in is you're going to kind of check it, and you're going to have a look at it and scroll across it and say, does that look right? And you're going to eyeball it to begin with. You've got a variable view here. And I guess one of the first things that happens is we see that we've got this field here called var001. That's variable 001. That's SPSS's default naming convention. It will call new variables var001, var002, var003 as it's going on, if it doesn't have a name for them. So if we look at this variable, we can see by right-clicking on it that it's actually a series of job categories that people belong to. So we should probably give it a more descriptive name like job cat. Why did it get called var001? Well, one of the simple ways in which that can happen is that SPSS Statistics has quite strict naming rules around variable names. It doesn't, for example, like things like hyphens or spaces in variable names. So if it said job space category in the database that it was stored in, and then I read it into SPSS, it would probably rename it the var001. If it said job hyphen category, or if it had a percent sign, or if it started with a number, it could cause an issue. So in SPSS, field names can't have special characters in them apart from an underscore or maybe a hash symbol. And you can have numbers, but they've got to start with a letter. So the field name's got to start with a letter, and it doesn't like spaces or dashes or slashes or hyphens. And the most you can get away with is an underscore. That's something to bear in mind. Now, if I want to change this field name, I can just double click on it and just call it JobCat. Yeah. And just to bear in mind that, maybe doing that every single time manually, every time you read in a field, in a file, it might get a bit onerous. You should bear in mind that there are some really simple syntax commands you can do to run that. So, for example, if I wanted to change JobCat, the field name JobCat here in the background, to something else, then I have got these commands that I can say, like, variable labels, variable label, variable width. I can change variables, and I can also get commands like, rename variables. So I could rename variables. I think the command for this is if I just go open bracket JobCat equals, let's call it job role, something like that. Change it there, full stop. I highlight that and just run it. Let's see if that works. So now that's been called job role. So you can see that you could just save away a command. I'm going to change it back to JobCat for consistency purposes, but you could literally build up a little series of commands like this, saying rename variables, and you could have a list of variables in here saying, var001, var002, var003, and then give them the correct names afterwards and do that automatically. Something to bear in mind, particularly because there are certain places in SPSS where you don't have a paste button to record the syntax that you're working on. So, for example, if I go into value labels here, I don't have a paste button when I edit these. It doesn't paste it. So I need to use syntax and type in the syntax myself rather than just clicking paste, which will normally paste the syntax. So this is the first thing. The next thing I'm looking at, typical sorts of stuff, is I'm looking at these little symbols across the top. And I'm trying to make sure that these are correct. So for example, I've got a field here called sal begin. And that's encoded as a scale field. You can see it says measure scale. That's correct because that is a number field. And when I right click on that and I ask for descriptive statistics, you can see it gives me people's mean beginning salary and the range of values from minimum to maximum. And it's given me, useful information there. If I did the same thing on the current salary that's been recorded here and try to do that, you can see that the results are not satisfactory. It just gives me this nonsensical table. And that's because it's been encoded incorrectly as a categorical field, as what's called a nominal field, rather than a ruler field, which is a scale field over here, which is a continuous field. Again, there's a syntax command which will change that, which is called the variable level. It's called the level of measurement. But if I want to change it manually, I could just double click on this and go to here where it says measure. You just go right down here to let measure and change that to scale. And then right click on that, run it again. That's fixed. So right away there, that's another typical issue that one might get. Then the other things we're going to be doing is generally right clicking on stuff and just checking. If you right click on stuff in SPSS and just do descriptive statistics, it'll tell you things like this really interesting stuff like minimum and maximum values, which you might want to change, turn your attention to. Here, if I look at the variable age, descriptive statistics, it looks fine. The mean's 34.45. The median age is 29. The range is 71. But if I look at the minimum here, the minimum is -9. So -9, of course, is probably a missing value. It's probably supposed to indicate that we don't know this. We don't have information on this person's age. Now it turns out I could actually work this out later on because I've actually got their date of birth there, and I could work that out. But there's issues, of course, with the date of birth field. We wouldn't make it that easy, so we might have to change that. But in the meantime, if I didn't have, say, date of birth and I needed to deal with that, then I could just double click on this and tell it that the missing value for age is actually -9 and click OK at that point and hit descriptive statistics and run it. Now the minimum age is 20 and the maximum age is 62. And as a result of that, the mean will change slightly. So it changes from 34.45 to 34.73. So that's kind of interesting. You should, again, bear in mind that if you go to File, New Syntax here, and just type in missing, you see right away it's suggesting missing values. And if I can't remember what the actual command is for missing values, I can click on this little syntax help button here. I'd just like to point it out to people. That little syntax help button there will give you examples of it. So it's saying, here's missing values for variable 1, 8, and 9. Here's missing values for variable 2 and variable 3, 8. So it's just literally the field name with the missing value following it as an integer value or as a character in brackets or parentheses. So I could say missing value age -9. We've already set it, of course, -9, so it's not going to do anything. But we could run that command and it would run it, just run that selection. It will go off and do it and it would set it to -9. Again, just bearing in mind that some stuff doesn't have a paste button, but there will be a syntax equivalent for it, and you might want to bear that in mind. Okay, what else have we got? Well, I'm looking at other fields here. We've got a field here called job time. I can see right away. Now, one of the things we notice with job time is, first of all, again, it should be a number field, really, but it's set as a category. It's set as a category field. I know it's a category field, first of all, because I can see little characters of X here, so they're not just pure numbers. And I can see that it's got a little A symbol. If you've got very good eyesight, it's got a little A symbol next to this nominal symbol here. This is a symbol of 3 circles, meaning it's alphanumeric, meaning it's a character string. So obviously when I right click on that, it's going to treat it like it's a character and I do descriptive statistics. It's nonsensical, doesn't mean anything. Look, there's 2 occurrences of the value X. If I just wanted to clean it quickly and say, I don't really care about these value X's here, I could just double click on it and just change it from a string, force a change from a string to numeric. Click OK at that point, come back to it. And what we notice is that these are now little system missing values. The level of measurement hasn't changed. It still thinks at this stage that it's a nominal field. So now if I run that, it's still going to give me one of these crazy frequency tables out the back of it. So it's not treating it as a proper number field. It still thinks it's a series of categories. So again, I might double click on it and go to the end here and change that to scale. And now it's a scale field with missing values in it. Now, if you had a whole bunch of these and you said, actually, I want to fill these full stops with, I don't know, let's say I didn't want missing values in there. These are system missing values. They're just full stops. It just means it ignores that value. It treats it as missing. See, it says there are 5 missing values here. The minimum is 63 months since hire, and the maximum was 98 months since hire. So, we've got this value here. Let's say for whatever reason, I just wanted to punch in a number here. Maybe if it's missing, it means that, they've 0 months since hire, or if it's missing, we should put in the average, for example. There are things you can do about that. You can go to transform here, and you can go down to replace missing values. And if you choose that, and you choose, for example, this variable job time, months since hire, I'd need to create a new version of it. I'd have to call it job time 2 or something like that. But I could replace it with what, if I hit change here, with the series mean, the average of series. Click OK at that point, and you can see that here's the series mean. So that's just changed the average to 81. It's just filled in that with the mean. It's useful. It's more useful for things like time-based data, where you have perhaps a trend or time. So maybe you're collecting sales values over time, because then I could change this to the mean of the nearby points. And the mean of nearby points just means take the average of the preceding and subsequent values and interpolate that average, that mean value there. But suffice to say that there is a procedure specifically for filling in blanks, if you like, in SPSS with legitimate values, if having the missing values causes problems due to the fact that you know what the actual true value should be in that. Maybe it's a default value or something like that that's not recorded, or where you would prefer to use an average or something like that rather than just have the value missing for whatever reason that might be. So you can do that. Okay, you heard me talking there on about the fact that we this person here, we don't know what their age is, but weirdly enough, we know what their date of birth is. This is a deliberately slightly messed up date of birth variable here that I've created. Again, you can see it's a category variable. It's a nominal field here. It's alphanumeric because, of course, it hasn't just got the month number in it. It's actually got the month itself. So we're pretending we're importing this, and it's coming in this fashion that SPSS doesn't understand this field to be a date of birth field. That thinks it's a string field. You could see that I could try and force it to be a date of birth. Sometimes you can get away with that. Sometimes it will just accept it. Now, I'm going to do it here. I think I can get away with it in this example. I think it will actually deal with it. But if you are going to do that, then my little tip is to right-click and say, I want to insert a blank variable. So you can see it calls it var001, of course. That's the blank name. And then what you could do then is just right-click and copy and maybe paste over the top of that. You can see it calls it var002, var001, but it makes it a string category variable. So I might want to change this. I'll call it the DOB2. Let's give it, again, a little label, date of birth, make a label. Let's see if we can get away with just forcing DOB2 to not be a string, but be a date. If I click on date here, it says, what format do you want? Well, I'm happy with day, month, which will be a description of the month, and then the full year, or 4-digit year. Click OK at that point. Did I get away with it? Yes, it did. So, I mean, technically, this isn't a nominal field, so I should really change this to scale because it's kind of a number field. That's what date of birth is. And you can see that it's got this little scale, this little date symbol next to it. You can see that's equivalent to a date. Because a date symbol next to it. It knows that that is a date field now. It's accepted it as a date field. It looks like it's correct. There might be issues, there can still be problems somewhere down the date, in which case you just get a blank full stop in there, a null value, a system missing value. But it looks okay thus far. Let's assume it didn't work for whatever reason, because sometimes you are going to get versions where it just doesn't work. Then you could use an alternative route. There is actually a little tool in SPSS called the date and time wizard, which you'll get under transform. It's really, really useful. So you can learn about how dates and times are represented in SPSS statistics. Or really useful, you can create a date or time variable from a string containing a date or time variable, which is what we've got. This is a string containing a date or time variable. So it's kind of set up to deal with exactly that situation. Another issue, though, is that you might have read in the data, and you may have found that, for example, the day, the month, and the year have all come in as separate fields. That sometimes happens, day, month, year, as separate fields, in which case you could create a date time variable from variables holding the different parts of dates and times. It's very easy to do this because it is a wizard. Let's choose this one. Create a date time variable from string containing date or time. We hit next. It says, which one's a date time variable? We say it's this one. You can see it's actually scanning the data. It's actually showing you the first few rows. And it says, okay, this is what I'm saying. It's basically saying, this is what I'm saying. What format do you think that matches? And I'm going to go, I think it matches that one. That's good enough for me. That's how I want it represented. That's the pattern that matches it. Hit next. Okay, how do you want it represented out the other side? Well, I could have it as American format, month, month, day, day, year, year. Or I could have it day, day, month, month, and just the year as a suffix, as a 2-digit suffix. I'm going to stick with the original format. And again, I'm going to call it DOB2, date of birth 2, and give it a little label. Date of birth. Do I need a capital on that? Probably not. Hit finish at that stage. And at the end here, it sometimes takes a little while for it to run. I think it goes, it's did this before for me. I think there's an issue. There is some actually hidden away in this data set. There's some blank cases which may cause issues of it. So there's other things I've kind of put in here, which can cause issues. But let me just see if I can run it again. Data time variable. Let's see. DOB. That's my sample value. That's my sense of I want it next. DOB2. Date. Birth. Create the variable now. Paste the syntax into the syntax window later on. You could do that. Let's see if this works. Let's see if I'll choose that. Yes, it is day, day, month, month. That's the output format. That looks day, day. It's the only difference I can see here is this one has slashes, this one has dashes, and I think it should be all right. Hit next. Hit finish. Let's see if this works. Does it work? It's giving me an error here. It says a field to be read on the date format is on the field must contain day, month, year, separated by spaces, dashes. It doesn't like it actually using that method. But weirdly enough, it does look like it's doing it here. Let's see if I can. Yeah, weirdly enough, that hasn't worked in that case, but I could get away with it weirdly by simply copying it, pasting it at the end here, and then forcing it to be a date or birth field like that, clicking OK. And it works then, amazingly enough. So I'll change this to, let's change it back to DOB2. Give it a label, date of birth. And change it to scale field. And then if you want to move fields around, just hold down the header at the top and just scroll along here until you've got it to where you want it to be. I'm going to move it side by side. Yeah, and we could actually at this stage just delete the original one. So interesting enough, I get away with copying it there. It did have an issue with me using the date and time, probably because the date and time wizard, probably because it didn't match exactly. But not to worry about. We've managed to get through it. So I could actually ironically return at this stage and say, for the variable age where we've got -9 here, I could actually calculate somebody's date of birth using date of birth, the date and time wizard here, because I can calculate dates and times. I did actually do this in the previous webinar where we used date of birth and calculated an age variable. So just bear in mind, I'm not going to do it now, but bear in mind you could calculate the length of time between two units. So I could calculate their date of birth, their age today, based on taking away date of birth, then returning the result in years. And then if I know what year that the data was collected in, I think it's something like 1989, something like that, I could take away 30 years or so in order to get the correct age at the back of it. Suffice to say, I'm happy enough with that at this stage. So that's stuff around formatting, really. All that stuff is to do with formatting, with things being, categorical when they should have been scale, or things being string when they should be numbers, where missing values haven't been correctly identified. All of this is issues that can mess up our analysis within the SPSS. And we know that SPSS Statistics really likes its data to be formatted correctly. But what about problems with the data itself, actual errors and issues in the data itself? Well, we return to SPSS again. Let me just switch off the output here so we don't need it at this stage. And syntax, I don't really need this. I'm just going to close that down. It turns out we've got a little procedure here which we can, which is used to be part of the data preparation module, but which is now native within the SPSS base system. And it's basically data preparation. You can see here on the data validation, we have a bunch of different procedures. One says load predefined rules, one says defined rules, and one says validate data. And we want to validate the data. We're going to click on that. This is specifically for checking the data for any potential problems. And it's saying, first of all, here, when we look at this dialog box, do you have a case identifier variable? In other words, do you have an ID field? And we do. We've got employee code ID here. So there's everything else you can throw into the analysis at this stage. I'm going to throw everything else in. I'm going to leave out date of birth because I've kind of dealt with that. I don't have a problem with it at the moment. And if we look across the tabs now, we've got these things called basic checks. So these are just standard checks that it will do to the data to make sure that it's working. So one of the things it will do is say, I will flag any field or any variable where more than 70% of the data is missing. So that's kind of useful to know about. You might have a really big data set here of hundreds of fields, variables in it, in which case knowing where all the missing data is useful. I will flag any field where 95% of the cases belong to a single category. So if you've got something like a category like a region, 99% of them are all in one region, you might want to know about that. I will flag any variable or any situation where the maximum percentage of categories with a count of 1 is 90%. In other words, that's saying that I will flag any field with what's called a high cardinality. So that will flag up, for example, a product code where most of the cases have a percentage occurrence of like 1%, because there's so many different categories that they don't occur that often. Some of them 0.5%, some of them 0.2%. So it's flagging up any ones where you've got a lot of unique values, which may not be very useful for you in terms of analysis. And then for scale variables, if you've got scale variables which just don't vary a lot, so everybody's the same age, for example, or everybody spends exactly the same amount of money, it'll flag those. So this is minimum coefficient variation and minimum standard deviation. It will also flag any incomplete IDs. So it will say, look, if you've got a case here and you haven't got an ID for this case, so I'll flag that. It will flag duplicate IDs. I've noticed that you've got 2 cases here, or 3 cases, or 4 cases, or a bunch of cases here that have the same ID or have more than one ID unique to them. And it will also flag in the empty cases. These are cases where all the values are empty apart from the ID field. So all of this is really kind of useful. This is kind of basic checks that one can run. And if I click OK at this point and just have it run those basic predefined checks, we'll see what comes up. So the first thing it says is you've got a variable here called city, and more than 95% of its values all have the same or all the same. So if I look at this variable city here and check it for descriptive statistics, it says basically, yeah, 99% of them are Chicago, and you've got 3 blanks. So that's kind of interesting. Might want to deal with that later on. What else have we got? We've got an incomplete ID here. We've got a case called case number 479, where it doesn't have an employee code. So if we look down at the bottom here, we just scroll down, hit control and down arrow. There's case number 479. You can see here, it actually doesn't have an ID. So I could just type in at this stage. I'll say, well, I don't know if you're 479 or not, but I'm going to give you an ID of 479. We'll just work on that basis. Maybe rerun it again and check for duplicates, make sure I haven't used a duplicate up or something like that. Because then it says, actually, you have got a duplicate variable here. You've got 2 duplicates, and it's case number 20 and 21. So if we look down, scroll to case number 20 and 21. Okay, there they are, case number 20 and 21. And we can see that they look identical, apart from the fact that gender is in capital F, or 20, and lowercase f, 21. I could get rid of one of these at this stage. Now, you might be thinking, he's doing this manually. Isn't there a way to do this automatically? There is a way to do it much quicker, which is if you look at validate data and look at basic checks, you can actually click save here at the end. So you can ask it to identify the empty case or the incomplete ID. So I can actually click on these. I'm going to check these 2 and click OK. And it will actually create a field for you at the end saying, look, these are duplicates. These are part of the duplicate group. And there's only 2 duplicates, so they both belong to group 1. But I could, for example, here sort in ascending order. Ascending order or descending order? Descending order. Yeah, and there it shows my duplicates right at the top. And I could then just say, well, I'm going to delete that one. Get rid of that. And then what else did it have? Well, it said, your ID is complete. Let's just make sure that this is correct. And what about empty cases here? Let's make sure this is correct. Let's sort that in descending order. Well, look, it suddenly found that you got some cases here where you got IDs. There's nothing else for them. So these are all creating blanks in the analysis. They're just useless. They're not bringing any information. So I can hit clear there, and then I can sort back in ID order. So there is a way for it to flag these in the data set itself. And you could then, for example, use a select statement, a select cases statement to filter out anything which isn't a standard or a non-problematic case. So here we have our case checks, case identifier ID, 76, 80, and 83. We've just got rid of those. So that's been worthwhile, just doing that, just going to data, validation, load, validate data. There's other stuff in here about validate data, though, that we haven't really touched on. One is, I'm just going to switch this off. Basic checks there. Let's switch these off because we're not really interested in this. One of the things we can do is we can create rules, single variable rules. So you can see here that you can have little rules here where you've got things like you can check and define what is acceptable and what's not acceptable. So what am I noticing? I might notice, for example, as I look down through here, that you get people whose month since hire has been too long, or the previous experience has been too less, something like that. Here's one here. We've got education level in years. Education level in years. We've got some of these claims to have 115 years of education. Okay, so right away we can say, look, we need to define a rule for that. It's scanned the data. This is really useful. Minimum, maximum is very useful. You need to find a rule for that. Scan the data. And I'll call this rule educ or education check. Okay. And then I tell it what the minimum is. I say you need to have at least 8 years of education. Let's say, I don't know, arbitrarily, maximum of 25 years of education. And I can allow, am I going to allow non-integer values within that range? That means people saying 8.5 years. No, I'm not going to allow it. Allow missing values. Yeah, I'm going to allow missing values and hit continue at that point. And then what I do is I switch it on. So I apply it. And if I go to save here, it will give me, I have the option here to have a validation rule count or problem, have it flag a problem for me and click OK at that point. It says, yeah, you've got a problem here, case number 147, because they say that they're failing that particular validation rule check that you just created. So I could again sort this in descending order, and here we have it across the top. You can see this person here has 115 years of education. Let's assume that we know that checking again, they should have just said 15 years of education. Okay. And this variable Chicago, now that we've got rid of our blanks, there's only 475 cases. They're all got the variables. They've all got the value Chicago. I probably don't need that field now. So I'm starting to work my way through this. And the thing to bear in mind is that it's quite useful, this validation, because it turns out that it actually has a whole bunch of its own predefined rules that you could load. So you can click load predefined rules, and it says, okay, I'm going to load some of these rules for you that come with SPSS, if you like. And then I could go to validate data, and I could go to single variable rules here. And look, we've got all these different rules. One is checking to make sure a variable called sex only has 1 character. Checking that day of the week is only 3 characters, that day of the week is full. There's lots of checks around US states, making sure that they are 2 characters and they haven't put in a state that doesn't exist. Same with Canadian provinces. Not very relevant for the UK, but the UK, you have like a postcode checker. And if you're using the standard social class designation, it will check that. So it does allow you to load some of these predefined rules, as well as create your own family of rules, should you wish to use them. Okay, what about things where stuff is absolutely legitimate? The rules are, the range of values is absolutely legitimate, but where they contradict one another in some way. So the values might be perfectly legitimate. The person's 16 years old, but they have a driving license, that type of situation. Well, let's say that we shouldn't have a situation here where somebody's current salary is less than their beginning salary. Now, I'm sure there are, in reality, many situations where that's the case, because somebody goes part-time or they get demoted or something like that. But let's just say for whatever reason that shouldn't happen. We could define our own rule here, and we can come up with our own cross-check rule. And we could say, we're going to call this sal check or something like that. And I need to define a logical expression for this. So I could say something like, if current salary, double click on that, is less than beginning salary, that is when it violates. This logical expression should evaluate to 1 for a middle invalid case, which is just a fancy way of saying I'll flag this with a 1 if anything, if find a situation where salary is less than beginning salary, and click continue at that stage. It's switched on at that point, and I can ask it to save any rule violations out the back of that. Let's see if I click OK at that point. There's also an output window here which tells you to list rule violations and descriptive statistics and that sort of stuff. Click OK at that point. Let's see. It says specify rule violation subcommand already exists. Oh, it says this actual rule actually already exists in the data. Validation rule violations. Is this somebody whose salary is 23,000 and their beginning salary is 13,000? That's not an issue of that particular situation, I don't think. No, that's not an issue of that particular situation. That must have been from earlier on. So I don't think we've got a situation, maybe perhaps in this data set, where we've got this particular rule violation. But if we did, we could go to validation. We can define validated data, and we can go to cross variable rules, and just make sure that that sal check rule is already in place. And if there's anything that violates it, you can make sure that you can get, you can deal with that. What about things at irrelevance? Well, we've got job cut here. If I run job cut and hit descriptive statistics, I notice, for example, we've got 3 cases where they're interns. Okay, that's not necessarily an invalid value, but you might want to, for example, you might want to get rid of it. So you might say these people don't really belong in this data set because we're not really interested in them. So you could do, for example, to select cases and get rid of them and say, I want you to select cases where employment category is not equal to, let's see what that code is. It's not equal to code 4 intern. Like 4, I continue. And that would filter those cases out for me. So I could then right click and check that. You can see it just says clerical, custodial, and manager. They're actually still physically there in the data set. It's just that it's filtering them. That's what it does by default. It creates this filter variable. If we wanted to physically get rid of them, then we'd hit delete unselected cases, click OK, and then they physically wouldn't occur in the data set. You wouldn't really notice any difference between the two, but the actual cases wouldn't be there anymore, and our filter variable would no longer be useful or necessary to us. And the last situation we've got here is a very common situation, which is where you have things like gender, and you have string categories which have been inconsistently coded here. So we can see that we've got F and M and M and A and M and M coded variously in uppercase or lowercase. So there's different ways in which you could resolve this. Perhaps the easiest way is simply just to change everything to lowercase, in which case you could run a compute procedure here. Again, to be on the safe side, I'm going to change this field name here to sex. And I'm going to use, I think the command here is, let me just see if I can find it. Lower. Yeah, it's just called lower. You can search for it and say lower. And in the brackets there, just put the variable name gender. Let's see if that works. Click OK. Oh, it says basically you're trying to create a default numeric field from a string field. So you don't want to do that. You want to be able to create a string field. I'll just tell it that this target field sex should be string, and I'll call it sex of employee. Again, I could overwrite the original variable. I'm just choosing to not do so to create a copy of it to be on the safe side. Click OK. Let's check that, and let's run that one. And you can see there's only 2 values there, M and F, and I could then double click on that and of course give it value labels like F for female and M for male. Click OK. And that's that cleaned up. Okay. So we've run through a whole bunch of different procedures there. I must have demonstrated about 20 different procedures here. They're not uniquely the only ways in which you can deal with some of the issues, but a lot of the errors and problems that we have here are, they're pretty common problems that one would have to deal with on a regular basis when you're cleaning data, whether it be formatting problems or problems of the data itself. Of course, I could just click open here, open data, and just go right back to this original data set, employee for cleaning, and say let's revert to that. There's the original data set with all its errors and problems associated with it. And if I've already done this, gone through this process beforehand, I might have been smart enough to actually clean the data and record it in syntax. You can actually see here it starts by bringing the data in. So I'm actually just going to say no, get rid of that. So now I've got I've got a blank data set. I've got rid of it. And if I just go to syntax here, I could run all the syntax. It's renaming the fields, it's setting salary to a scale variable, it's assigning -9 to age, it's changing job time to a scale variable, and doing this. All the stuff I've done is just done and hit and run all at this stage. It just goes through that and formats the data correctly for me in one go. Okay, just finishing up here. Data cleaning with syntax, the last thing we talked about there, you should be aware that there are lots of FAQs and lots of problems that people commonly encounter when dealing with analyzing data and manipulating data. We have a set of resources that help you deal with that. We've got SPSS FAQs, everything from finding out what you have installed to how to merge files or change the language. We've got a series of video guides dealing with a range of how-to topics. And we've got information on SPSS software and the products themselves. And we've got a blog series on statistical analysis and statistical testing. We also have a range of online training materials, which are free to Smart Vision Europe customers or available for purchase for non-customers. And you should be aware that we have a range of different consulting services that we provide, everything from 1 to 2 days project support to much longer analytical deep dives where we can explore your data to test hypotheses or even to develop new applications. So you can source your data your software directly from us. We have our own web store, often with discounts to provide the SPSS product line and other IBM products. We also offer, as I say, training consultancy services, including identification and recruitment of analytical skills in your organization. And advice and technical support to people who are Smart Vision customers and non-customers. If you just want no strings attached advice or help with something which is, analytically related, then the best thing to do is just drop us a line, send us an email, and we'll see if we can help you out with that. In the meantime, thanks very much for logging in. Our last webinar today is looking at a complete different topic. We're going to be looking at working with the Watson platform, which is this browser-based platform, an AI-based platform using the IBM Watson AI.x platform. So we hope if you're interested in that, please log in and join us on it. Thank you very much.